Welcome back to level 2 of the Learning Dimensional Analysis tutorial series. So we will, in this level, we will look at a little bit more complicated example dealing with multiple dimensions. So let's look at the question right here. And just like level 1, you have the option of pausing the video, trying to do it yourself, and see if you can get the right answer, or just stay here, stay tight, and watch the entire video to make sure that you have the concepts understood clearly and thoroughly. So here, let's look at the question. It says the density of copper is 8.96 grams per centimeters cube. If the mass of a copper block is 2.1 kilograms, what is the volume of this copper block in liters? Okay, so if you look at this question, clearly you can see two numbers right there, and the trap for many students is that they often focus too much on the numbers but not analyzing the dimensions. So let's just do that. Let's just first start with analyzing the dimensions. So first we look at the density. It's a value that has both mass and volume. Okay, and the next number is a mass, as you can see from the unit kilograms. And what the question is asking, for the volume. So we have the dimension in volume. It is a very important step to have this analysis, because now you know how to handle the situation, because now you can think about, all right, we want to get volume, and it's a single dimension. So what should we start? Okay, this is often the question that students would ask. Do I start with 8.96? Do I start with 2.1? The answer is that if you are asking for, if the question is asking for only one single dimension, we always start with a single dimension. So if you look at those two numbers, the only value that has a single dimension is the mass, 2.10 kilograms of the copper block. So this is what we will start from the beginning, is the mass. And then, but what about the intermediate steps? Okay, so we want to go from mass to volume. So we will love to have a conversion factor that has both mass and volume together, and the density fits right in. Okay, so you will place the mass component, the dimension of the density, in the denominator, and you have the volume in the numerator. Okay, so with that, we can go ahead to see how we are going to set it up. So we use the density right here. So we set it up by having the single dimension, the mass, okay, 2.10 kilograms to begin with. Now, what is next? Okay, can we just go ahead and use the density next? Well, if you look at the units, okay, so on the mass, it is in kilograms, and the unit of mass in density, it's in grams. So we would love to use the density right away, but we cannot, because the units are not matched. And when the units are not matched, well, we have to make them matched in order to continue. So first we would go ahead and do a single conversion, so that we will have grams, and then we can use the density. So this is why my first conversion factor here, it's between kilograms and grams, and we would like to eliminate kilograms, so we put the kilogram in the denominator and we put the grams in the numerator. So 1 kilogram is to 1,000 grams, so that's why you see the conversion factor being set up this way. And then now we can go ahead and use the density, because now we have the desired unit that we can utilize our density. And this is the problem. A lot of students, they have a question right here, and that is, so we can put the 8.96 grams in the denominator. As we said in the intro video, if you have not watched it yet, make sure you watch it. We have the freedom to put the dimensions in any way we want, and how to tell which way that we should do it. It all depends on the calculation. So in this case, we would like to get volume and eliminate mass. So we put the mass in the denominator, and we put the kilograms in the denominator, and we put the cubic centimeter in the numerator. Okay. Now, just a quick note. As you can see from the question, you can see the slash. Okay, 8.96 grams slash centimeters cube, we do not use slash as we do our calculation. So please stay away from slash. And the reason for that is because, well, we only use slash in a sentence because we don't want to waste space. But in mathematics, we are going ahead and use fractions. So the slash, it's a symbol for fraction line. So we just make it as a fraction. So make sure you understand why we do not use slash as we set up our conversion factor. If you do use slash, then you are putting yourself at a very huge risk of getting an incorrect answer. Okay, and now we have the volume, cubic centimeter, but that's not the unit we want. We want the unit in liters. So we need to think about how are we going to get cubic centimeters to liters. And this is the part where you have to have some background understanding of some units, which is that 1 centimeter cube is the same as 1 milliliter, and that's why we put the next conversion factor right here. And if you know the value in milliliter, then you can change it to liters because 1 liter is to 1,000 milliliters. So this is how we set it up, and again, like level 1, we will love to show our unit cancellation just to make sure that we have everything set up correctly. So we have the kilograms being canceled out, we have the grams being canceled out, cubic centimeter being canceled out, milliliters being canceled out, and then we are left with liters, and we are happy. That's exactly what we want at the first place. So we put into our calculator, and please make sure that as you input the values in the denominator, use parentheses. Okay, use parentheses for your values in the denominator, or else you are going to get an incorrect answer, which I would explain more in details later on in the common mistakes explanation. So if you do that, you get this answer, and that's the value that we will put in here. Okay, so since the question has 3 significant figures, we will have the answer presented in 3 significant figures as well. So it will be 0.234 liters. Okay, 0.234 liters. So now let's go ahead and think about our common mistakes. Okay, so the common mistakes that we see very often is that first one right here is the use of density. When we talk about density, many students, they think about density is always 1 gram per cubic centimeter or 1 gram per milliliter. And the origin of this mistake, it's coming from earlier times in your middle school years, probably, that you learn about the density of water. Okay, well, 1 gram per milliliter is the density of water, and it will be suitable if we are dealing with water. But we are not dealing with water right now. We are dealing with copper. So 1 gram per milliliter, it's not applicable here. Okay, so when you use density, you have to understand that, what kind of matter are we dealing with here? Is it water? Is it not water? Because different matters, they have different density. Like air has density less than 1 because, it floats above water. That's why it must have a density less than 1. Things that would sink in water, it's going to be greater than 1 gram per milliliter because it sinks. Okay, so make sure you keep that in mind. With density, it's not always 1 gram per milliliter. It depends on the material that you are dealing with. Okay, so that's common mistake number 1. Common mistake number 2, it's where many students, they do not memorize the conversion factors correctly, such as I've seen a lot, 1 kilogram to 100 grams. So they don't understand that K stands for kilo, which is also the representation of the number 1,000. Okay, this is very important. Okay, and one way to get yourself over this dilemma is to understand what K really means. It is the same K that we talk about a 5K run. Okay, that's 1,000. 5K means 5,000. It is the same K when we talk about salary. Like I make $40,000 a year, so this would be 40K a year. Okay, if you talk about house prices, house price being like $90,000, you can say is 90K, or $200,000, you can say 200K. So the K we use right here is the same K that we use in our daily life. Okay, And another one, 1 liter to 1,000 milliliter. The most common mistake that I've seen would be students thinking about 1 liter being equivalent to 100 milliliter. So my suggestion to get over this mistake is that you can go ahead right now and see if you have any water bottle or any liquid container with labels, and take a look at the volume. Okay, so you can see that maybe your water bottle is 500 milliliter, so that it's 1/2 of a liter. Okay, and then you would know, oh, so if 500 milliliters is 1/2 of a liter, then 1,000 milliliter it's 1 liter. Okay, so make sure you keep those in mind. Okay. And the third one, which is a very, very common one, is the lack of understanding of how calculator interprets your input. So this is the screenshot that I have showing you right here. This is what many students would type in, and what they did is that they did not put a pair of parentheses for the numbers in the denominator. Now, when the calculator sees you typing in this, so it's like, all right, so you're doing multiplication and division. So the calculator is just going to do the math from the left to the right in your input order. So what it does is that it will think that you are doing 2.1 times 1,000, and then it will get a product divided by 8.96. The calculator would give you a quotient, and then that quotient is being multiplied by 1,000. So that's a problem. So make sure that you put a pair of parentheses around the numbers in the denominator so that you can compute the mathematics correctly. Okay, so so if I type it incorrectly, this is what it shows, and well, you don't really want to multiply that by 1,000 at the end. You want to put the 1,000 in the denominator. Okay, now if you have a scientific calculator, this would be a little bit difficult to see because you don't really see the input like this so nicely in the fraction view. So make sure that when you have multiple non-1 number in the denominator, please make sure that you put a pair of parentheses to include all the numbers inside, all the numbers in the denominator in the pair within the pair of parentheses. Okay. Now, common mistake number 4. Okay, this is what I see very often, just because students, they don't know how important the units are. And the units are really good in terms of telling you whether you are on the right track or not. If you don't write units because you are lazy or you just don't care, you actually expose yourself at a huge risk. So if I were you, I would be lazy, but I would not be lazy right here, because what's the point of being lazy if we get it wrong, right? Okay, we want to be efficient, okay, and efficient is to be lazy and to get it right. So, so please do yourself a favor that please put units in your calculation so that you can check your own math. All right, so please take a moment to see if you understand this example in level 2, and if you're good, you can go ahead and click toward the level 3 video on your right upper corner if you're viewing it in your on your computer. Okay, so let's go to level 3, and we'll talk about something a little bit more challenging in level 3. All right, thank you for watching.